A few years ago, I was boarding a flight to Buenos Aires in New Jersey. And as I sat down in my seat, I found myself next to a young woman, and we started chatting. And it turned out that she was working for a cloud-based education company. I had just started my own cloud-based education company, Learning Catalytics. We used that platform in my keynote in Liverpool 2 years ago. So I thought, I better find out what she's doing. We started talking about what she was doing, and it turned out that her company was making flashcards for smartphones. I don't know if you're familiar with my work in education, but I don't place much value on memorization, so I had trouble not rolling my eyes. I managed to stay polite. Now, earlier that week, I had attended a talk at Harvard by a psychologist from Washington University in St. Louis who studies memory. His name is Reddy Rödinger. You may be familiar with his work. It got a lot of press a few years ago when he wrote about practice retrieval and about how quickly students forget information when studying with flashcards. He basically measured it. He took students, had them study with flashcards, and then waited increasing amounts of time to see how long they would remember that information. And it turns out, if you study with flashcards, you remember quite well. Everybody knows what I'm talking about, right? These cards that have questions on one side and the answers on the other. It turns out that you know the material quite well. You remember the material quite well for a few days. But if you test students a week later, they remember only 35%. If you wait 2 weeks, you can hardly measure what they still remember. I thought she should know about this. And I had downloaded the Science article in which he published his results on my iPad. So I bent over, grabbed my iPad, pulled up the article, and I gave her my iPad. And she glanced at the screen for no more than 10 seconds and then handed me back my iPad. And she looked me right in the eyes. And she said, "But we only guarantee that they will pass the test." My jaw dropped. I had never thought about it this way. And it brought back all kinds of memories. My daughter, my eldest daughter, was a student at Harvard University, pre-med, which was great, right? Because on Mondays we'd drive to campus together. On Fridays she'd drive back home. And I remember driving back to campus one Monday. I was in the driver's seat. She was in the passenger seat to my right. And we drive on the left in the US. And I looked over my shoulder, and I saw she was using flashcards. "Natalie, what are you doing with flashcards?" "I have to know all these amino acids." I said, "Amino acids? I have an app for that." Seriously, I mean, I'm a physicist. Occasionally I work in biophotonics, and I need to know the amino acids, but my brain cannot retain all that information, so I looked them up. And she looks at me and she says, "Dad, I'm not allowed to use the phone during an exam," which made me realize that even students with the best of intention, their study habits are not dictated by their attitudes toward learning. They're dictated by the assessment. I mean, my daughter and I would often talk about study practices. It was the exam that was forcing her to memorize the information. Now, when I was speaking here 2 years ago in Liverpool at your national conference, we talked about the approach to teaching. And I showed this slide of me teaching a long while ago. And I made the point that most lectures simply focus on the transfer of information. Today, I'm going to make a different point. Namely, that on the output end, we have the same problem. Most assessment is focused on the regurgitation of memorized information or the application of rote procedures. And consequently, instead of developing 21st century skills, our assessment practices are really focused on ranking and classifying our students. So here's what I would like to do today. I'd like to talk a little bit about the purpose of assessment. Why do we have that assessment? Then next, I'd like to turn to some of the problems I have identified in my own classroom with assessment. I mean, all of these years, for more than 20 years, I'd been thinking about the approach to teaching, only to discover way too late that what really drives student study habits is the assessment. And it's impossible to achieve any lasting change without really rethinking not only the pedagogy, but also our assessment practices. Now, I don't want this to be a negative talk, so I'll end with a few suggestions on how we might improve our assessment practices. So let's start with number one, the purpose of assessment. And I want to make this interactive. So I'm going to give you a few minutes to discuss with your neighbors. One of them should be a note taker. And what I want you to do is to write down as many different purposes of assessment as you can come up with. So go ahead. Get together with a few of your neighbors. Have somebody take notes and write down as many different purposes as you can come up. Maybe we can have the house lights on for a moment. I love photography too, so. Can I get my microphone back? Can I get volume back? Test, test, test. Okay. Okay. So, how many of you got more than 5 reasons? Okay, good. You've been working hard. I like that. Early on a Friday morning. It's pretty good. So let's hear it. Let's hear a few options. You shout it out. I'll repeat it because I have the microphone here. And it would take too much time to have a runner. So let's hear some reasons for assessment. Who wants to go first? Well, come on. Huh? Baseline. Although the baseline comes at the end of our teaching. Isn't that kind of late? Often, right? Was the final exam. Yes?
Inform future teaching, build self-esteem for the students.
Wait. You're rattling off a whole list. So one is to provide feedback on the learning.
Yes.
Yeah, to the teachers. And the second one?
To encourage students to improve their self-esteem.
To encourage the students to improve themselves. Okay, let's hear from others. So just Give me one from your list so that different people can get to talk. Who else? Yes?
Assessment for learning, assessment of learning.
Assessment of learning and for learning. Okay? So, in a sense, feedback to the instructor and feedback to the students. Okay, a few more. I haven't heard the one that is one of the most, obvious ones. Practice for the final exam. Although the final exam itself is also an assessment. So what is the purpose of that final exam?
Provide paper qualifications.
To provide paper qualifications. What else? To build resilience. I love that.
Measure progress.
To measure progress. And to distinguish between level and style. Wow, I think we would not hear that from many students, though, to give reflection on the learning. But what is sort of the most obvious reason? Nobody has mentioned that yet. I'm kind of surprised.
Capture understanding.
Capture understanding. Couldn't hear that. To classify students, to rank students. I mean, and I think that's one that the students focus on the most because that's what's going to determine their progress. Here's what I wrote down. I mean, one is to rate the students. I mean, to basically end up with a ranking list of the students in the classroom. To rate the professor and the course in some absolute sense and in the eyes of the department or the school. To motivate the students to keep up with the work. To provide feedback on the learning to the students, to provide feedback on the learning to the instructor, what has been learned and what has not been learned, to provide some kind of instructional accountability, and also, and I think that was one of the first things we heard, to improve the teaching and the learning. Look at the verbs in that list, and you already see that we have a contrast. How can you accomplish all of these things at the same time with just one which is one type of activity. So let's talk next, now that we know already that the purposes, create in a sense a problem because it has way too many purposes. Let's talk a little bit about some of the problems I have identified. I already made the point that many of our assessments are inauthentic, focusing on the regurgitation of memorized information and the application of rote procedures. But I would argue that even assessments that claim to be focusing on problem solving do not do so. What is a problem? Well, when you have a problem, you generally know what the desired outcome is. You have to give a keynote in Manchester, and you have booked your flight on Lufthansa. And as you head to the airport, you hear that there's a one-day strike, and your flight has been canceled. You got a problem. The outcome is known, being on time in Manchester to deliver your keynote. The question is, how are you going to get there? It's the solution that's unknown. You're the CEO of a company. You know that you want to make your product successful. That desired outcome is known. It's not about the outcome. It's about the path to the outcome. Any problem you face in life follows that pattern. The outcome is known. The procedure is unknown. Now, in most assessments, especially in the sciences, the problems that we give our students are of a very different kind. Take my own field, physics. Right? You may have a problem that says a car is going along a road, and then at some point it hits a tree, blah, 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 and so on. It gives a few things, and then at the end it says, what is the velocity of the car just before it hits the tree? The student, in his or her mind, just says, well, what are the procedures that I've learned to calculate velocities? This procedure, that procedure, that procedure. You eliminate the procedures that you can't use because they don't have the right variables. And in the end, you end up applying a known procedure to find an unknown answer. 4.2 meters per second, for example. See the difference between these two? A real problem at the top was the known outcome and the unknown pathway, and the difference with the type of problems we often give our students where they're asked to apply a known procedure to find an unknown answer, and it's the answer that is the key point. I think this is particularly relevant in the 21st century because, you know, that bottom type of problem can be done automatically, as I will argue in just a second. But let's put this in terms of what is called Bloom's taxonomy, which is a taxonomy of thinking skill set up in the 50s, in the 1950s, by Benjamin Bloom, who was an educational psychologist. He sort of ordered these thinking skills from lower order thinking skills at the bottom, like remembering and understanding, to higher level thinking skills like evaluating and creating at the top. I think that in most educational settings, even at, you know, first-tier institutions like my own in the US, we rarely even get to applying, where applying means taking what you've learned and apply this in a new context. You know, just to give you an idea of what I mean by this, a number of years ago, I was giving a talk at a university south of Boston in Connecticut, a pretty well-known institution, I won't name any names, and in the physics department. And on education. And after my talk, one instructor came to me and said, I had something really peculiar happen to me this year. He was teaching physics to engineering students, and he wanted to make the physics relevant to his students. And in order to make it relevant, he put physics in a real-world context. And the context that he used was baseball. I mean, there's a lot of physics in baseball, right? Trajectories of balls, collisions between balls and bats, runners running. So in class, he'd use examples from baseball. On the homework, he would put baseball problems. On the midterm examinations, he would put baseball problems. At the end of the semester, he was preparing the final exam, and he realized he had run out of baseball problems. So he put some football problems on the exam. Professor complained to students, we have never done any football problems. You're laughing. We should be crying, because you have to agree. If you can't transfer what you've learned from the context in which you've learned to a new context, you have not really learned. This is why I said we're basically stuck at applying. Let me actually show you what I mean by this, by taking an interesting problem and turn that into a textbook problem and show you what happens to the thinking skills. See, a number of years ago, I was painting my dining room, and on a Saturday morning, I ran out of paint. So I had to get into my car and drive to the hardware store, which is right in Harvard Square. I don't know how many of you have been in Harvard Square, but there's this hotel called the Harvard Motor Lodge. Now it's called the Harvard Square Hotel, which sits on stilts in Harvard Square. And underneath it is a public parking garage with 20 spaces on one side and 20 on the other, bordered by 2 roads. Typically, I would drive in, no spaces. I would drive out, get into the other road, and back in the other half, no spaces, and I'd go around and around and around and around until somebody frees up a spot. But you know what usually happens is you're on the right side, and you see somebody walk to a car on the left, so you quickly pull out traffic, back in, and by that time, somebody else has grabbed the spot. So on that Saturday morning, I said to myself, you know what, I'm just going to give up on the left side of this parking garage. I'm just going to turn my engine off and wait. And as I turned off my engine, I asked myself, how long is it going to take before somebody comes and frees up a space? And strange physicist that I am, I start to think about it. And it was in half a minute, I came up with an estimate, 3 minutes, based on a model that I developed. And I looked at my watch, and sure enough, 3 minutes later, somebody came and freed up a spot. I felt so good. Now imagine you turn this into an examination problem. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before someone frees up a space? I guarantee you, if you put this on your exam, your students are going to go to the dean or director of the school and try to get you fired. What are the type of skills you need to answer this question? Well, you need to make assumptions. You need to develop a model and then apply that model. In terms of Bloom's taxonomy, we're all the way at the top. where, we have this elusive evaluation and creation in order to answer this problem. Anyway, from the skills that are on the left, which is the one that the students hate the most? Which one? Assumptions, yeah, because, what if you make the wrong assumption? It never occurs to a student that if you make the wrong assumption, you can always revisit your assumption. I don't know about you, but in my class, if I forget to exactly specify everything, like whether you can ignore friction or gravity or not, immediately students raise their hand and say, Professor, am I supposed to assume here that? They want me to take the responsibility for the assumption. But let's face it, later in life, taking responsibility for your assumptions is probably a very relevant skill. And what distinguishes, let's say, one scientist or scholar from another is not the rote application of procedures, but the ability to make valid assumptions. Anyway, since the assumption is the most egregious part of this problem, let's put it in there. On average, people shop for 2 hours. 2 days is obviously too long, 2 minutes too short, so with 2 hours, we're roughly in the right ballpark. And in terms of Bloom's taxonomy, we've maybe dropped a tiny bit, but we're still quite high up. Well, students would still not like this problem. They would come to you and say, we've never done any parking lot problems. So let's put the model implicitly in there, assuming people leave at regularly spaced intervals. How long do you have to wait before somebody frees up a space? Now we've given them a lot, and actually in terms of Bloom's taxonomy, we've gone all the way down to analysis. And still, students would be horrified. What does this have to do with the subject that you're teaching them? So let's now turn it into an absolutely standard textbook problem. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area, where people are known to shop on average for 2 hours. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? You may say, well, wait a minute, isn't that the problem we started out with? Yes, but somewhere in the textbook or in the class, the students were introduced to this equation, colloquially known as the parking lot equation. And they've memorized that equation, and the only thing they need to do is use a calculator. And now we've dropped all the way to the bottom of Bloom's taxonomy. The only thing that is required is remembering. I've exaggerated maybe a little bit, but to some degree, that's true for a lot of our assessment practices. And as I said, this is important because the application of procedures can be done by computers. And I predict that any job that requires memorization or the application of rote procedures will be replaced by a computer in the same way that assembly line jobs were replaced by robots. So in the 21st century, we really better focus on real problem solving, which is right at the top. But there's a problem with that because it's erratic. In fact, the road to any creative or innovative process is littered with failures. Right? You try approach 1, doesn't work. You try approach 2, doesn't work. You try approach 3, maybe if you're lucky, it works. Students are horrified by this because making mistakes means losing points. So in a sense, our assessment practices discourage taking risk, trying out something, sticking out your neck. Well, if you don't fail, you haven't really tried hard enough. Let's switch gears. This picture here needs no explanation. You saw right away what this was. And if this picture evokes pleasant memories, I would like to talk to you in the break after my talk. What are some of the feelings that this picture evokes? Go ahead, blurt it out. Stress. Pressure. All things that are so conducive to learning, isn't it true? But there's something else. There's stress, there's pressure. There's something else that's really peculiar about this picture. What is it? Look at it. Isolation. Thank you very much. That's exactly what I was after. Isolation. These students are cut off from each other, cut off from any source of information. Ask yourselves, after taking your last exam in college or wherever it was, have you ever encountered a situation where you were similarly cut off from any other individual and any source of information? When I'm in my office writing a paper about nanophotonics, there's nobody standing next to me saying, you're not allowed to look up the paper by your colleague at Yale. You should have known this by heart. I can look up whatever I want, whenever I want it. It's not about remembering the information. It's about knowing how to use it. So why, then, do we test our students this way? And then, of course, there's the final exam, because traditionally, assessment has been a high-stakes affair. But as we know, high-stakes testing promotes cramming, studying with flashcards like my daughter did. And cramming, as research has shown, stores the information only in short-term memory. I think it was Einstein who once said, education is what is left after all that is learned is forgotten. A very sad statement. You know, I think it was December last year, exactly a year ago. You may have seen this on the news too. There was a bomb scare on the Harvard University campus on the first day of the exam. I was actually in Hong Kong, turned on CNN at night, and there I saw my campus in the early morning on the first day of the examinations, fire trucks everywhere. It was a student who didn't want to take the exams and who had called in bombs in 3 buildings. Well, that was not known then, so it was taken very seriously, the threat. And an hour later, in my hotel room in Hong Kong, I received a note from the dean that was addressed to the entire academic community, students and faculty. He had decided to postpone the exams that were going to be given in those 3 buildings that morning for 2 days. And he realized, he said so, I kept the email, he realized that was a problem for the students because they had studied for the test. Hello? And you only remember 2 days? Isn't it already admitting that we have a huge problem? So, no retention and no transfer. Then there's grades. Grades are a measure of a student's standing relative to others. We'll get back to that in just a second. The other part of assessment, and we heard some people mention that, is feedback. Feedback on what has been learned. But research has shown that if there are grades, students completely focus on the grades and they overlook the feedback. I think it was here in the UK, actually, that an experiment was done. Was it Adam Black, I think was his name, who for 10 years in a number of schools took away the grades, focused, still had assessment, but focused on feedback, telling the students, this is good. Here you made a mistake. This could be improved. And showed that in the absence of grades, students take the feedback much more seriously and actually reflect on what they have learned. Yet we seem to be unable to abandon this need for grading. The other thing is that assessment produces a conflict. I realized that when I started teaching a project and team-based course, where I basically have a very different space from this. Students sit in groups around round tables, flat space, and I walk around the whole semester coaching the students to build the best possible project they can. At the end of the semester at the fair, the first year that I taught that course, I judged them, and I felt like making a Jekyll and Hyde transition from being the coach to all of a sudden being the judge. I mean, I can't think of any other human enterprise where you can be both the coach and the judge. I mean, imagine you're coaching a figure skater, and then you go to the Olympics and you say, good luck, I'm going to judge you now. I mean, it would be unacceptable. Yet in education, that's what we do. Generally, the people assessing are the people teaching. How do we get away with this? There's only one way we can get away with this, namely by hiding behind a very thin veil of objectivity, of a fair and reliable measure But think again about Bloom's taxonomy. Which of these thinking skills can we evaluate completely objectively and reliably? Only the bottom one. So in a sense, this coach-judge conflict forces us to stick to the lowest order thinking skills. And then there's much other. I mean, it was mentioned already yesterday. Cheating, grade inflation, you name it. Why would a learner be cheating? Are 4-year-olds cheating when they're learning all kinds of things, from tying their shoelaces to putting their forks in their mouths? No. They want to learn. They own the learning. Why do we take away that ownership of learning by turning people who are born to learn into people who are just learning for reasons that are unclear to them to pass the test? Let me switch gears here and end here. I have only a few minutes left to talk about improvements. The first thing that I would suggest is let's mimic real life. You know, why do we cut off students from information during the assessment? After all, later in their life, they'll have access to anything they want. Why not give open book exams? You know, in fact, I had already sort of realized that without articulating it in my own mind early on. When I started teaching at Harvard, during the exam, I would give the students a sheet with information that I thought would be useless to memorize and that they might need on the exam. The next year, the students who had seen my sheet would say, can't we bring in our own notes? I said, okay, you can bring in one sheet, 8.5 by 11 inches, one side only to discover that students develop a microscopic writing that, you know, where they copy the whole textbook on that sheet. So the next year I said, just bring the book. And then the following year, some students said, I had a different textbook in high school, which I liked more than the textbook that you've assigned. Could I bring this other textbook? Sure, bring in the other textbook. Some students come with piles. And the following year, some students asked, could we bring in our solutions to the problem sets and our notes? You know what? You can bring in anything you want except another living person. And then, more recently, I started to assess students on the computer, which means they have access to Google. Should I tell them not to look up anything on Google? Is that actually a problem that they are, have access to an infinite source of information? And the answer is no, of course not, because let's think again about Bloom's taxonomy. What does giving them access to Google do? It basically takes away that bottom level of Bloom's taxonomy. It forces you to push the questions higher up Bloom's taxonomy. Because any question to which the answer can be Googled is no longer an authentic assessment question. I'm going to shift gears again a little bit. I'm going to show you a little video clip which was filmed in Bandung Institute of Technology in Indonesia, which is one of their leading institutions. I chose that because I presume there are a few of you who speak and understand Bahasa Indonesia. I want you to look at this clip, which is just 50 seconds, and then tell me two things after it. What is the discipline of this classroom? What field is being taught? And what is the activity that the students are engaged in? Okay, so the first question, what's the difference, is a little bit unfair because, how can you tell? I'll tell you. Statistics. Have you ever seen students having fun with statistics? Well, here you have it. Now, what is it exactly that they're doing there? What do you think they're doing there? They're sharing. Anything else? What part of the curriculum is this? What part of the teaching enterprise is this? I'm going to tell you it's an exam. They are taking a test. Is that not a cognitive dissonance? You know, how can you have fun and be taking a test? This comes from an approach to teaching called team-based learning. If you want to know more about it, go to teambasedlearning.org. And it's an assessment practice called if-at assessment, instant feedback assessment technique. Basically what happens is that the students get a series of questions which they answer individually first. And there are multiple choice questions, which I have some problems with, but that's okay. 1B, 2C, and so on. And after they've answered the questions individually, which is 50% of the credit, basically they write down 1B, 2C, and so on, and the instructor collects those little strips after 20 minutes, the instructor puts on the table an if-at scratch card. This is the card. It has on the vertical 1, 2, 3, 4, 5, 6, 7, 8, 9, the questions, and on the horizontal A, B, C, D. At the intersection, it has this paint that you can scratch off like on a lottery card. And it's been pre-coded to have a star behind the desired answer. So 1C, for example, was the right answer. I attended one of these exams, and you know, the students first assigned a scratcher, because there's only one card per table. You're going to scratch. And then they started talking. One was an easy question. I got C. What do you have? C, C, C. Everybody got C? Okay, they scratched C. There's a star. They got it right. I thought, okay, so now they're making a game out of an assessment. But then something interesting happened. In question 2, part of the students had answered B, others had answered A. The A's didn't want the B to be scratched off. The B's didn't want the A to be scratched off. This was an exam about hemoglobin in a biochemistry class. So the students went, no, you know, it has to be B, because don't you remember the instructor told us that when this happens, blah, blah, blah. And so they started to talk like biochemists. And at some point they said, okay, yeah, there was a majority that thought it should be B. They scratched B, no star. But here's the genius of the method. If you get it wrong, you can try a second time for half credit. Notice that the first question, only one square has been scratched off, so there's 4 points. The second one, two little pieces have been scratched off, and the credit is 2. And for question 4, there's 3 that have been scratched off. There's 1 point, so you can try a third time for a quarter credit. And if you still get it wrong, you get no credit, but at least you know what the right answer was. At the end of the exam, and you'll actually see during the exam, students go, oh, yes. Now, how many exams have you seen where students have aha moments, where the assessment is an opportunity to learn? The best thing was, when the exam was over, the students walked away. They knew their grade, because you can add up the grades on the card, and you can score yourself. They were relaxed. They had learned. And there was no grading for the instructor to do. Now, I liked it, but I didn't like the multiple choice part. And that's where learning catalytics come in, which I demonstrated 2 years ago. It basically allows you to ask any type of questions, graphical questions or word-based questions or equation questions like this one. And during the individual part, students answer whatever their individual answers are. And in the team round, they see what all other members of their team have answered. So Brian said 6x minus 6. Brent said 6s. So during the discussion, they'll go, Brent, why do you have 6x? And they'll try, and they get the same immediate feedback, except that now it's not multiple choice. It's a free response exam. Let me show you a little video clip of how this works in practice. So during the individual round, it doesn't look any different from a standard exam, except that students are sitting at their computers. But then after 20 minutes, I press a button and things look very different. In fact, I make a habit of trying to have people visit my classroom during that time. You can see we're teaching the right-hand rule here. And these students were not smiling because we had a camera there. In fact, they had no time to spend any attention to the camera. Notice that they're also working on different problems on the different boards. every group works at his or own pace. There's no longer that time pressure too. So, we can change the approach to teaching, and it doesn't have to be an isolation from each other, because in real life, we are working together. We have access to information. That's not what life is about. Second thing is, let's focus on feedback, not on ranking. Actually, I think this whole idea of ranking is a myth anyway. How can we capture an individual with a single letter or number? I know a lot of examples of people who dropped out of school and were hugely successful. And as a faculty member responsible for graduate admissions, I know we've admitted plenty of people with straight A records who, when they show up, are missing the most fundamental skills and don't succeed. Let's take an example from my own class. On the vertical, you see the final grade from a class I taught many years ago. On the horizontal is the result of a test of the conceptual understanding of Newton's laws. Notice that some students score below 10. If you would take a gorilla and ask the gorilla to just take this test by randomly pressing keys, which is probably what the gorilla would do, the gorilla would score higher than 10. Some Harvard students belong in the primate section of the zoo, as you can see. This is a post-test. This is at the end of the semester. This is actually what woke me up and showed that what I was doing in the classroom was not that good. According to the authors of the test, anybody who scores below 22 has not understood Newton's laws, is still an Aristotelian thinker. And as you can see, a significant fraction of my Harvard class is still an Aristotelian thinker at the end of the class. Yet some of them have near perfect final grades, which has a huge distribution, right? All the way from 90-something to below 10. According to the same authors, anybody who scores in those last three bins scores at the level of a graduate student or a professor. If you test them, they score in those last three bins. And you see some students are there, but there's still a huge distribution of final grades. Look in particular at these two students. The one on the left got an A, the top grade, yet was still an Aristotelian thinker. The one on the right got a C, yet scored at the same level on this other instrument as a professor or a graduate student. Is this objectivity? Or is it an injustice? Let's give up on this. I don't think we can accurately evaluate a person's true potential by looking at a single or just a couple of assessments. So let's focus on the feedback. The third thing is, let's focus on skills, not on content. So much curricular design is based on content. In this course, we're going to cover topic A, topic B, topic C, topic D. Instead, what we should really do, as advocated by this book, Understanding by Design, by Grant Wiggins and Jay McTighe, is we should not start with course content and then later think about the assessment. We should start by thinking about the output end. What are the desired outcomes? What do we want to accomplish? What do we want our students to be able to do after taking this course, or after graduating from this grade, or after graduating from school or college? And in order to formulate those contents, we should think, what is it that we're going to accept as evidence? Many of my colleagues, by the way, have a lot of trouble articulating desired outcome. They like this idea, but they're so wedded to content that they think about it a little bit, and then they say, after taking this course, you will be able to understand topic A, topic B, topic C, topic D. But then you're back to where we began, so that's not right. And lastly, you're going to think about, what am I going to do in the class in order to maximize this desired outcome? The great thing about this is that not only is the course defined by outcomes, pardon me, test still on? Okay. Not only is the course defined by the outcomes, you've thought about the assessment before teaching. Lastly, we should resolve this judge-coach conflict. How did I do that in my project-based course? The answer was so simple. I just had never thought about it. Let's use external evaluators. So I went to my colleagues and I say, hey, I'm teaching this new course. Great course with projects. Would you like to come and evaluate the students? This way they can be the bad guys and I can continue to be the coach. In fact, I can help defend the students in front of the external evaluators. My role in the classroom does not change. I'm always the one promoting the learning rather than judging the students. Is that more work for us all? Well, if my colleagues evaluate my course, I'm happy to help evaluate in their course. So it's a zero-sum game. The other thing, and I wish I had more time to talk about it, but my time is up here, is we should make much more use of peer and self-assessment. Because this ability to judge oneself is so important. In the traditional assessment practices, that never happens. You hand in your work to the expert, the teacher, and then later you get it back with a grade on it, and you have no idea how your work really compares to that of the others. By giving students an opportunity to do some peer and self-assessment, they can place their own work in the context of that of others and develop this very important metacognitive skill that I think research has shown is the true key to be able to continue to learn later in life. Because unless you can judge and regulate your own learning, you cannot advance. If you're interested, there's a fantastic system called Calibrated Peer Review. The URL is at the bottom of the screen, developed at UCLA, that basically automates, even in large classes of hundreds of students, this self and peer review. Well, I need to end here because we have our break ahead. And I want to end with a call to action, which is very simple. We really need to rethink assessment. Because unless we do so, we will continue to educate the followers of yesterday rather than the leaders of tomorrow. And equally importantly, unless we rethink our assessment practices, our tests will continue to fail to indicate who will be successful and who will not be successful. Thank you very much.